Hi friends, I'm Anand Panchma and today we will deal with short transmission line. We people have studied few things. આટલી આ લાઈન આવે છે વિડિયોમાં અહીંયા આવે છે આવે છે આવે છે નહીં ને એટલે અહીંથી ચાલુ કરવાનું. વેરી ગુડ. So we're going to deal with short transmission line. Now, see, there are certain kilometers that we have to memorize, right? Kiatla kilometer the line is short transmission line. So now we are going to see the electrical model of it. What is the electrical model of a short transmission line? So in short transmission line, we consider that we have a resistor and an inductor into it. That's it. And this is my sending end voltage. This is my receiving end voltage. This is my sending end current. This is my receiving end current. Fine. Okay. The line is modeled as a resistor and an inductor. Fine. Okay. This is what we are going to remember right now for short transmission line. We have already studied. Now we have to find out the equation. We have to find out the equation of short transmission line in terms of ABCD parameters. So now tell me, what is the equation of ABCD parameters? Who will tell me? ABCD parameters, I hope you know.
What is IS, ABCD, VI, I. VS equal to A.
गलत.
ABCD बोलवा पड़શે ને
हाँ तो बोल भाई क्वेश्चन
मैट्रिक्स
बोल बोल बात छोड़.
VS IS, ABCD, VRI. પછી VS equal to AVR plus BI ને IS equal to CVR plus DI. પછી ABCD ढूंढवा पड़શે इक्वेट करें एक मैट्रिक्स की.
आज बोल.
VSIS,
VSIS,
ABCD,
VRI. This is correct. Fine. Cause we have V1 I1 as a function of V2 I2. समझा कि ना समझा? तो V1 I1 is sending end voltage, sending end current, and we have to find out it in terms of VR IR, that is receiving end voltage and receiving end current. पता चला कि नहीं पता चला? ये तो पता चला नहीं. यहाँ से हम लोग भेज रहे हैं, यहाँ से रिसीव कर रहे हैं, sending end, receiving end. So what is my equation? VS is equal to AVR plus VIR, and IS is equal to CVR plus DIR. Is it clear?
Yes sir.
I want to find out ABCD. How will I do it? મારા ખ્યાલથી આ વિડિયોમાં નહોતું પહેલા. હતું ને? હા, fine. So how to calculate ABCD? So here we are going to apply basic KVL equations. How to do that? Let's see this. So see, this is my receiving end voltage, this is my sending end voltage, and this is where obviously some amount of drop will occur, that is plus minus drop. So overall, if you want to consider, we can say that it's plus minus IZ drop. Otherwise, we can call this as I into R drop, I into L drop. Now here it is a short transmission line, and you can say that whatever sending end current we have over here, the same current is coming over here. So we can say that sending end current is equal to receiving end current. So we have got I is equal to IS is equal to IR. Any doubt into this? Fine. So we basically understood one thing, that I sending end, which is equal to I receiving end. I'm going to model this equation in terms of, I'm going to write down this equation in terms of this equation. How will I do that? So I can say that IS, that is equal to 0 into VR plus 1 into IR. I've got my first equation. I've got the value of C and D. Is it clear? Is it clear? Compare these two equations, guys. IS, C, 0, VR, D, 1, IR. Is it clear? Fine. Acha, from where we've got this equation? So we've got this equation, right? And I just have arranged it well so that they look alike. Is it clear? Any doubt on this? Any doubt on this? Clear? Any doubt? You can get shifted here, that's fine. If it is coming in between. Clear? Any doubt on this? Done. Now I want to model it for this as well. I want to write down this equation as well. So how will I do it? So see, I'm sending certain amount of voltage over here. I'm sending certain amount of voltage over here, right? Okay. And I'm receiving something, and we have a drop. We have a voltage drop in this transmission line. So how exactly, we definitely can understand that Vs is more in comparison of Vi. Vs is more in comparison of Vi, because Vs I'm sending, I have this much amount of drop, and we're getting Vi. Is it clear? Fine. So whatever 100 volts I have and 10 volts drop I have, so I'm getting 90 volts. Fine. Is it clear? So we can say that I have Vs voltage minus Iz drop is there, and that is giving me the value of Vi. And all the terms that I'm writing right now over here, they're vector terms. Vector in a way, this is R plus Jx. Do you understand? Vector means what? That is R plus Jx. Otherwise, voltage and current, they are not vectors. They are scalar quantities. Fine. So we can say that Vs minus Iz that is equal to Vr. So we have got Vs. So I want to formulate Vs over here. So Vs that is equal to Vr plus, Vr, capital R is a small r. So let's write down small r. It is capital R over here. So it's capital R, capital R, capital R. Okay, so Vr plus I into, Z into I, where I is equal to Is is equal to IR. Is it clear? So I can say that I can write down Is as well, I can write down IR as well. What am I supposed to write? IR, because I want to find out it in this term, right? Okay, so we have got IR over here. So we can say that, okay, fine. Now my A is 1, my B is Z. Clear. So I've got a matrix. I've got an ABCD matrix over here. So we can say that my ABCD parameter for short transmission line, the given is Z. 1 Z 0 1. Is it clear? Now we're supposed to draw the vector diagram for the same. So see. IR current will not come until and unless you have not connected load over here. Is it clear? And the loads are of three types. Either it could be pure resistive, or it could be inductive, means RL circuit, and it could be capacitive. Fine? Pata chal raha hai ki nahi pata chal raha hai? Right? It could be either pure resistive load, it could be RL load, and it could be RC load or capacitive load. Right? Okay, so here if I consider that the load is connected like this, so we can say that the current what I have, that is IR, which is considered with respect to VR. Load is getting some voltage which is VR, which is receiving an voltage. I am getting some voltage over here, I am getting some voltage over here, right? That is my reference. Right, that is my reference. Do you understand that? I am getting that voltage. 230 volt over here. RF value, right? Okay. So I have got some voltage which is 230 over here, like this. Fine. So in vector form, I consider this is my reference. So basically, this is my receiving end voltage. Yes or no? Yes or no? Ye clear hua ki nahi hua? Pakka done? Okay. Now what is happening? If at all I have RL load, inductive load, what is happening? The current what I am having, IR, it is going to lag behind the voltage VR. Yes, so we can say that my current is starting from here. So this is how my current is starting. So this is my current waveform. It is lagging behind the voltage. I consider it is lagging behind the voltage by some degree phi. I should have drawn a little bit smaller so that I can add the drops. Okay. So this is my VR, this is my I, which is equal to IR, which is equal to IS. Is it clear? Which is equal to IR, which is equal to IS. So this is my I over here. This is my VR over here. VR. Okay. Now this is my I, which is 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 equal to IR. Now I want to find out VS. So VS is VR plus Z into IR. Now let's understand what is Z. So Z is basically R plus JX. and this X is what? This X is the inductive reactance of the transmission line. You should not get confused in between the X of transmission line and X of load. Do you understand? Generally, people commit mistake into this. Fine, they have been given the value of load as well, which has some resistor, some inductor. Fine, line is also having some resistor, some inductor. So, where you have to keep, you have to understand that. Clear? Any doubt on this? Fine. So load is of 2 plus J3. Fine. So you and transmission line parameters are like a resistance is this much and inductance is this much millihenry or some microhenry. So you have to figure it out which one is the load component, which one is the transmission line component. Is it clear? Fine. So we understood that this is my voltage and this is my current, and this phase angle what I am getting, it's my power factor angle at the receiving end. Is it clear? This is my power factor angle at receiving end. पता चल रहा है कि नहीं पता चल रहा है? पता चल रहा है ना? It is receiving end power factor angle. Okay, so we have got receiving end power factor angle like this, and we can say this is my power factor angle fancy. Receiving end power factor angle. Once I have got the value of current, I have to find out Z into IR. Where Z is equal to this, so I can say that Z into IR, which is equal to R plus JX into IR. This is transmission line. These parameters are of transmission line. So we have to multiply IR over here. So we can say that IR into R. IR into R. This is the drop. This is the voltage drop across. This is the voltage drop across a resistor. This is the voltage drop across a resistor. Yes or no? This is the voltage drop across a resistor. And that voltage drop, guys, that voltage drop is always in phase with the current. That voltage drop is always in phase with current. How? We have studied it for pure resistive circuit. If it is the circuit like this and I have some current over here in this direction, so this is my current I, so I can say that VR is in the same direction. Right? For pure resistive circuit, voltage and current are in phase with each other. Yes or no? Fine. So we can say that yes, IR multiplied by R, it is in phase with IR. Do you follow me? IR into R, it's a voltage. IR into R, it's a voltage which is in phase with the current. Fine. Voltage drop across a resistor is always in phase with the current. Yes or no? Fine. So we can say that it is in this direction. So IR, I know the value of IR, I know the value of R. So the multiplication will give me some value, some magnitude. In that magnitude is suppose this much. That magnitude is suppose this much. That magnitude, suppose I into R is this much. It is this much. Fine. So what am I supposed to do? So it is C. VS is equal to VR plus IR into R plus IR, J into IR into X. So VR में I have to add this drop. पता चला कि नहीं पता चला? बगा सका के what I have to do is I have to add this drop into VR. पता चल रहा है कि नहीं चल रहा है? Fine. Okay. So we can say that VR this, IR this much. I cannot add directly like this. I cannot add it directly like this. Because this is what? Voltage across this resistor. Right? This is voltage across this resistor. And it should be in the direction of IR. It should be in the direction of IR so that it will maintain the unity power factor for that particular resistor. इसके across हम अगर मस्त वाला वो CR लगा के देखेंगे तो उसमें जाने वाला करंट अगर ऐसा होगा तो उसमें आने वाला वोल्टेज भी ऐसा ही होगा. समझे कि नहीं समझे? बोथ आर इन फेज. समझे? ये क्लियर हो रहा है कि नहीं हो रहा है? चल करंट सेंसर को लगाते हैं और वेवफॉर्म देख ले. वोल्टेज को लगा वोल्टमीटर को लगा दे, वोल्टेज देख ले. तेरे को पता चल जाएगा ना वेवफॉर्म कैसे. नो बोथ विल बी इन फेज. मतलब वो करंट की डायरेक्शन में जा रहा है तो ये वोल्टेज ड्रॉप एक्चुअली करंट की डायरेक्शन में होगा. जो लग नहीं रहा है, थोड़ा सा लग रहा है और थोड़ा ऊपर करना पड़ेगा मेरे को. चलेगा. It's coming through, right? So we have got this term which is Clear? Now let's deal with the next geometry you have to add, that is Ix into R. Generally, in comparison of a resistor, the value of inductance is more in any device, any transmission, and whatever. Because we design it that way. We design it that way. The reason is that I want to reduce the losses. I want to reduce the active power losses. I square R is the active power loss, but I square into X is a reactive power loss. So there is no net power loss into it. Active is a net power loss. Reactive power is not a net power loss. I hope when I say this, when I say active power is a net power loss, and when I say reactive power is not a net power loss, find net power loss is equal to 0, you should be having the entire theory behind it in your mind. How exactly voltage and currents are there in pure inductive circuit, that you should know. How exactly multiplication of voltage and current gives you a curve which is of second or say 2 omega t. The frequency is 2 omega t. This is my voltage, this is my current. Fine. So the power is voltage into current. It's like this. Right? So here the average power becomes 0. This entire theory goes, it should go in your mind when I say this. Fine. Every statement we learn into engineering is having a big theory behind it. Fine. जैसे कि इसका भी theory तो हमने पढ़ा है ना. We have understood the theory, bloody theory that you should be knowing already, right? Okay. So रेजिस्टर का जो भी ड्रॉप होने वाला है वो किस डायरेक्शन में होगा? I की डायरेक्शन में होगा, IR की डायरेक्शन में होगा. क्लियर हुआ कि नहीं हुआ? इंडक्टर में जो ड्रॉप होने वाला है, इसका इंडक्टर ना, इसका इंडक्टर ना, यस और नो, यस और नो, कम कोड़ा, इसका इंडक्टर. अभी ड्रॉप इसके इंडक्टर की बात कर रहे हैं अपने. समझ पड़ रहा है कि नहीं समझ पड़ रहा है? क्लियर हो रहा है बेटा? बगमा मत जा, तू पूछ मेरे को अगर तेरे को नहीं पता चल रहा है तो. तेरे को समझ पड़ रहा है? पता चल रहा है कि नहीं पता? बगवा है तू नहीं तेरे पिंचू है. समझ पड़ रहा है? पकड़ नहीं यार, बोल यार कोई है. बहुत टाइम के बाद में तेरे को पढ़ा रहा है, अब तक तेरा कोई डाउट ही नहीं आया. आई वंडर में सही पढ़ा रहा है कि गलत पढ़ा रहा है. क्योंकि जनरली ऑलवेज यू गेट अ डाउट, नाइस डाउट बेटा. मॉडर्न है गंदी आदत है खबर पड़ा. चल Ix का ड्रॉप क्या है?
Ix का ड्रॉप
तेरा है नहीं क्यों नहीं? ट्रांसमिशन लाइन में Ix નો ડ્રોપ થાય છે ભલા માણસ. You're not understanding.
No, I'm understanding. I'm just confused.
In nothing. I'll explain. What I'm going to do. सुनेंगे
मैं कॉमेडी
नहीं पूछ. मेरे एवरेज पे चिंता ना करिस. अंग्रेजी में ना पढ़ो तू कहतो હોય તો.
ના કॉमेडी
આ તો પેલું ઇમ્પ્રેશન પાડવા પેલું નવો છોકરા લાગે કે સર અંગ્રેજી આવડે છે.
સર તમારા વખતે ઇમ્પ્રેશન નથી
નથી પાડ્યું. પાડી જો હોય, પાડી જો હોય.
પહેલા દિવસ તો પાડી દે.
પાડી દે તો પછી વાંધો ના આવે. પછી કરના પાપે ખબર પડી છે કે ના સરને અંગ્રેજી ફાડતા આવડે છે. આ તું તો જોઈએ કેવી ઇમ્પ્રેશન લઈ જાય. Okay, see buddy, what I was teaching is VR plus Iz is equal to Vs. So I'm talking about this particular equation right now. So in that case, I into R is the resistor of transmission line that I'm considering right now, and I into XL, that is the inductor of a transmission line I'm considering, right? See guys, see this phi angle is because of what?
lagging of inductor.
Inductor में inductor में wrong understanding. It is due to load. I equal to load के कारण આવે ને.
કારણ કે
समझ हाँ this is the RL circuit. तो એને કારણે VR ને lag થાય છે IR. Current is a demanding quantity guys. Remember.
લોડ કયો છે?
લોડ આ છે લોડ.
मतलब RL કે કયો લોડ છે?
મેં આવું લખ્યું છે, મતલબ કેવો લોડ હોય?
RL છે.
Inductive load છે, right? Always always remember this phi angle that I have got, the magnitude of current that I have got, it is a function of it depends on this. Do you understand? पता चल रहा है कि नहीं पता चल रहा है? अच्छा, इसको जैसा चाहिए, इसको जैसा करंट चाहिए, वो साला सप्लाई में से खींच लेगा। वो क्या करेगा? साला सप्लाई में से खींच लेगा, राइट? तो ट्रांसमिशन लाइन का तो ऐसा का वैसा, उसको तो जो इसको चाहिए वो देना ही पड़ेगा। समझे कि नहीं समझे? क्लियर हो रहा है कि नहीं हो रहा है? इसीलिए ये करंट की डायरेक्शन में ये ड्रॉप होगा और L का जो ड्रॉप होता है वो करंट को परपेंडिकुलर होता है, राइट? द ड्रॉप ऑफ I into X is perpendicular. The drop of I into the drop of I into X is perpendicular to the current direction. So we have got I into X like this. आपको पता नहीं ये कैसे होता है? हाँ? Buga, this is the direction of current. Yes or no? This is the direction of current. Voltage across inductor. This is voltage across inductor. तो current इसके 90 डिग्री पीछे होना चाहिए. आ गया करंट 90 डिग्री पीछे। समझे कि नहीं समझे? क्लियर हो रहा है? क्लियर हो रहा है? फाइन। तो मतलब क्या है कि भाई इसमें से जाने वाला करंट जो ऐसा है वो इसके वोल्टेज के 90 डिग्री पीछे आना चाहिए। समझे कि नहीं समझे? तो उसका वोल्टेज कितने होगा? तो इसका वोल्टेज होगा कितने? तभी हो गया ना वो 90 डिग्री पीछे। समझ पड़ रहा है कि नहीं समझ पड़ रहा है भाई? हैं? क्लियर? चल इंग्लिश आवड़े છે મને એવું તો પૂછાઈ ગયું ને હવે ગુજરાતી પણ ચલ સો ઊંઘી જશે લોકોને તો એવું છે
Ultimately, we have to get equation of Vs.
there you go yes you already have got it but the thing is that we are developing that in the vector form right now, you know, we are developing it in the vector form. Yeah, sounds pretty nice, great. So but yeah, that's very true. So we have got VR plus IR plus IX. Yeah, this is nothing but a Vs. Is it clear? Fine. And this itself is my IR and IS. So this is my recipient power factor and this is my sending power factor. Clear? Any doubt on this? कोई भी डाउट? पक्का क्लियर? ठीक है, अभी अपना एक एग्जांपल करेंगे। किसी के पास कोई टेक्स्ट बुक है? ભગવાન તારું ભલું કરે તને જોઈએ એ છોકરી મળી જાય જા મારા આશીર્વાદ છે રાઈટ અને તું કરને છોડ એ પર્સનલ વસ્તુ પછી મને કહી દઈશ મનમાં કહી દઈશ મનમાં નહીં એમ કોપચામાં કહી દઈશ આ પેલું રહેવાતું નથી કહેવાનું પણ અડી જાય મેરેજ નોટ Guys, we are going to deal with the example performance of transmission line. We are following VK Mehta right now and Rohit Mehta as well. Generally, दूसरे वाले को कोई याद नहीं रखता है, तो हम रोहित मेहता जी को भी बोल देते भाई आपकी भी बुक है ये. Fine. किलोवाट वाला एग्जांपल किया था लास्ट टाइम.
Yeah, single phase over transmission line 33 kV and 1100 kilowatt pointed power factor.
Yes, done. 3 फेज वाला भी किया था.
No.
चलो अभी मजा आएगा. आपको रेगुलेशन आता है? चल मैं समझा देगा, कोई चिंता नहीं, मेरे को आता है.
No load minus full load upon full.
Regulation.
What is a no load voltage then? What is no load VR?
VS.
Yes. VS. Q.
Huh?
Yeah, there you go. So current zero है. So I zero हो गया. तो VS is equal to VR. So no load जो वोल्टेज को हमें पता चल गया. क्लियर हुआ कि नहीं हुआ? ओके. सो दैट इज डन. फुल लोड वोल्टेज मतलब VR जो हमने ढूंढा वो लोडेड कंडीशन के अंदर डिवाइडेड बाय VS minus VR upon VR. बराबर. फाइन इनटू 100. So that gives me regulation.
रेगुलेशन की जरूरत है.
રેગ્યુલેશનની જરૂર છે.
એવું ખબર પડે ટ્રાન્સમિશન લાઈન કેટલા ચૂચપા કરે છે સમજો ને રેગ્યુલેશન ઇફ યુ નો ઇફ રેગ્યુલેશન ઇઝ મોર ઇઝ ઇટ ગુડ ઓર બેડ ગુડ
સર વીઆર જ કેમ એટલે નેનોમીટરમાં થઈ ગયું વીએસ માઇનસ રેગ્યુલેશન ને તો મેક્સિમમ મિનિમમ વેલ્યુ જ જોઈએ ને.
હા આ તો રિલેટિવ ફાઇન્ડ કર્યું રિલેટિવ બાકી તો ડિફરન્સ જ છે
એટલે વીઆર થી ફાઇન્ડ વીએસ થી ફાઇન્ડ
કરાય ને કરાય એકચ્યુઅલી ટ્રાન્સફોર્મરમાં કરતા હતા આપણે જો યાદ હોય તો તમને પ્રાઇમરી સાઇડનો વોલ્ટેજ લઈને સેકન્ડરી સાઇડનો વોલ્ટેજ લઈને we used to do that fine but we always see with respect to receiving end voltage with respect to receiving end voltage what is the regulation fine we always calculate what is the regulation with respect to receiving end voltage क्लियर हुआ जो नो लोड होगा तो रिसीविंग एंड वोल्टेज कितना होगा भाई सेंडिंग एंड वोल्टेज कितना होगा फुल लोड हो गया तो रिसीविंग वोल्टेज कम हो गया तो रिसीविंग एंड की कंपैरिजन में कितना हुआ वी हैव टू कैलकुलेट क्लियर हुआ फाइन चलो तो ये डन हो गया ना कैसे रेगुलेशन फाइंड करना है ठीक है देयर इज वन मोर इक्वेशन ऑफ इट शायद वो नेक्स्ट एग्जांपल में हमने डेवलप किया था आईआर कॉस वाला समझाया था नहीं ओके देख लेते हो चलो लिखो अच्छा हाँ लकी लो ना